Hello friends. Welcome to my YouTube channel Chemical Adda. Please watch this video till the end to learn about the process of heat transfer through a plane wall. And what is the formula for determining the rate of heat conduction across a plane wall? So let's understand how heat transfers through a plane wall. During heat transfer across a plane wall, such as the walls of a furnace or wall of a stirred tank, heat flows through a solid material by conduction. From a region of higher temperature to a region of lower temperature. Hence we can say that in a plane wall like the wall of a furnace or stirred tank, heat transfer primarily occurs by conduction. But how? So as we know, conduction is the mode of heat transfer in which the heat flow through the material medium without actual migration of particles of the medium from a region of higher temperature to a region of lower temperature. Or we can say that conduction is the process by which energy is transferred from a hotter side to a colder side of a material due to a temperature differential without any overall movement of the substance. And in the furnace or stirred tank, the solid wall material acts as the major barrier to heat transfer that separates the inside of the furnace, which is at a high temperature, from the colder environment that surrounds it. And due to temperature differences across the wall, heat is transferred simply by conduction, wherein the particles of wall participate in the process, but they do not move bodily from the high temperature region to the low temperature region. So to derive an equation for determining the rate of heat conduction across a plane wall, we can use Fourier's law, also known as the law of heat conduction, which describes how heat transfers through a material. According to Fourier's law, the rate of heat transfer by conduction depends on the thermal conductivity of the material, the temperature gradient, and the cross-sectional area of the material. Based on this concept, now let's derive the derivation for the equation for heat transfer through a plane wall. Assume that the wall is constructed from a material with a thermal conductivity of value K. And the wall has a consistent thickness X. And a cross-sectional area A that remains constant throughout. A hot face of the wall is at temperature T1. And a cold face is at temperature T2. And both are isothermal surfaces. The heat flow is perpendicular to the wall, whereas the temperature varies along the x-axis. So according to Fourier's law we know that the rate of heat flow by conduction through a uniform or fixed material is directly proportional to the area normal to the direction of the heat flow, and the temperature gradient in the direction of the heat flow. Mathematically, the Fourier's law of heat conduction for steady-state heat flow is given by Q is equal to minus Ka dt by dx, where K is the thermal conductivity, A is the area normal to the direction of heat flow in meter square, Q is the rate of heat transfer in watts, T is the temperature in Kelvin, X is the distance measured normal to the surface, or we can say that X is the length of the conduction path along the heat flow in meter. dt by dx is the rate of change of temperature with distance measured in the direction of heat flow, which is also called temperature gradient in Kelvin per meter. You can see that the equation has a negative sign, because the temperature gradient is negative, which means that as X increases, T decreases. This means that temperature goes down in the direction of heat flow, and hence negative sign makes heat flow positive in that direction. Now, let's arrange the term for integration in another form. Let's integrate equation within the limit. When X is equal to 0, T is equal to T1. And when X is equal to X, T is equal to T2. So we get after applying the limit we get hence we get heat flow equation for plane wall as Q is equal to Ka T1 minus T2 divided by X. Now let delta T be temperature difference as T1 minus T2. Hence equation becomes, this equation can be written as where R is equal to X by Ka, which is called thermal resistance for plane wall, and delta T as the driving force for heat flow. Hence we get heat flow equation for plane wall as Q is equal to Ka T1 minus T2 divided by X, or Q is equal to delta T by R, where R is equal to X by Ka. So that's all about heat transfer through plane wall. So keep watching. In the next video, we will discuss another topic. So, if you like my video, please like, share, and subscribe to my YouTube channel, which is Chemical Adda.